Here's the first one. Now notice what the directions say. Solve this triangle ABC. Now notice it doesn't say right triangle. And even though we don't have a right triangle, pretty cool with my derivation that we just saw, the proof, if you will, we can always make a right triangle by dropping a perpendicular. And that allows us to use sines, cosines, or tangents. But in this case, it is called the law of sines for a reason. So this first example, if you remember, I warned you guys, one of the best things to do is draw. Now, notice they did give us 2 out of our 3 angles already. So right then and there, because I know angle A and angle C, what should you be able to tell me immediately? That's right. Hopefully you said angle B. Because we know that the sum of a triangle's angles is equal to 180 degrees. So in this case, I know that I can take the 28.8 degrees and add the 102.6 degrees to see what the sum of my 2 angles is. So 0.8 and 0.6 give us 0.14. 2 and 8 is 10, plus 1 more is 11. Carry that one, and you can see that we have 131.4 degrees between the 2 of them. So in order to find angle B, I would simply take my 180 degrees and subtract the 131.4 degrees. Now, hopefully you guys remember, I taught you guys how to do this in your head. You can subtract the 100, subtract the 30, then the 1, then the 0.4, and you can do that in your head. So the hundreds would just cancel out. I know 80 minus 30 is 50, minus 1 would be 49, and then subtract the 0.4, you get 48.6. But if you need to borrow and do it the old school way that you learned, you can do it and get the same thing with a little bit more effort. 48.6. So now we have all of our angles, but notice we only have one side. We still need to find little a and little b. And of course, in inches. So if you notice right at the beginning, we have what I'm going to call a good ratio. I see that I have side C and angle C. And if you remember, the law of sines requires us to know one of those pairs. Okay? Whether it was to find anything from A with those C's or anything from B, either the side or the angle length. So in this case, I'm going to take and I'll solve for little a or side length A first. So where should I be putting that? Hopefully you said on top. And then I will put sine of angle A, which just don't get those mixed up, 28.8 degrees. And that would be equal to, now I could use B because I found that angle, but remember, I don't have side B yet. And the safest thing to always do is use what they gave us, because hopefully you didn't write it down wrong, and therefore you shouldn't have made a mistake. So the best thing to do is always use whatever things that they gave you, angle-wise and side length-wise. So in this case, all you got to do with the law of sines is make sure that you're consistent. Since I put side length on top, I will put little c, which is 25.3 inches, on top as well. Side lengths on top, and in this case, the sine of the one that goes with that was angle C, which was 102.6 degrees. So if you notice, there's only one variable within this entire thing. And with this equation, hopefully you notice, in order to get this by itself, since it's being divided by something, all I have to do is multiply both sides by the sine of 28.8 degrees. Because anything divided by itself is a 1, and now I'll be able to find out what little a is. Now remember, we talked about significant digits or figures. Over here I have 3, here I have 4, and here I have 3. So the most that I can give, unless they ask us to take it to the nearest 10th, 100th, 1000th, or whatever, if they don't specify, I can only take the least number of significant figures that I have. So in this case, my sig figs would be 3. So now I have the task of taking all of this and multiplying and dividing it out. And so with a little bit of calculator work, here's what I get. 25.3 times, we had the sine of 28.8. When I hit enter, I will then take that and divide it by the sine of 102.6. And I got little a, or side length a, to be 12.489. Now remember, it's 3 sig figs, so I'm actually going to take that 12.48 and I'm going to round, because of the 8, to 12.5. And of course, we knew that the measurement was in inches. So I now have side length A, and the only thing we're left with doing is side length B. So my question to you is, could we use the Pythagorean theorem to find that? And hopefully you answered with no, not I don't know. Because remember, the only thing that we can use the Pythagorean theorem in is a right triangle. And these are what are called oblique, or non-right triangles. You can see angle A is not right, angle C is not a right triangle, and nor was angle B. So Pythagorean theorem, unfortunately, is not something that we can use in this, which means, what do we have to use to find our side length B? And you probably guessed it. After all, this is titled Law of Sines. We got to do it again. But this time we will use our lowercase b on top and put it over the sine of angle B, which we found to be 48.6 degrees. And then I would not recommend using A, because you may have made a mistake with A. So we'll go back to what we used, little c, which was our length, 25.3 inches on top, over the sine of angle C, which was 102.6 degrees. And hopefully you can see it's pretty simple to get lowercase b, side length b, by itself. Since it's being divided, we will simply multiply over by the sine of 48.6 to both sides to keep it equal of my equation. And that will then cancel this to get side length b. And again, just a little bit of calculator work. I will take the 25.3 and multiply it times the sine of 48.6. And then I will take that and divide it by the sine of 102.6 again. And since it's 3 sig figs, I will take and put my answer as 19.4. Don't forget your units. That matters. And now we have solved for the entire equation, finding the angle that was missing first, since we knew 2 of them. That was pretty simple. And then using our law of sines, not once, but twice, in order to find our other 2 pieces, which was side length A and side length B. So let's try another one. And here's just another note, just to make sure that you remember, the best option is always to use the given values rather than the ones that you found, so that you avoid making any errors or possibly being off by a couple of decimal places. Because remember, computers like my math lab, if that's what you're using, or my open math, or whatever it might be, they don't have a brain, nor do they have a heart. All they can do is compute. And they see yes or no. Is it right or wrong? Is it what they said that they could have or not? So be very careful when using that, but that's a good way to be careful, is just use what they gave you. Here's where it gets a little bit more difficult. You can see that there's much more words on this one than in the previous. And if you looked ahead, you may have noticed either those or this word right here called bearings. We're going to have to really work hard to draw this out correctly and then find what they want. So the first thing I'm going to do is make sure that I can draw this correctly. All right. So read the whole thing through. That's my suggestion on any word problem, so that you know what you're dealing with, and more importantly, what you're asked to find. and then go back and read it and draw it out to the best of your ability. And then from there, we'll go ahead and try to solve using all the techniques that we've talked about. So it says the bearing of a lighthouse from a ship was found to be north 52 degrees west. After the ship sailed 5.8 kilometers due south, the new bearing was north 23 degrees west. Find the distance to the nearest tenth of a kilometer between the ship and the lighthouse at each location. So first things first, we know we're looking northwest. Now, one of the key words on this entire thing, a lot of people will read over, is from. A lot of people actually have their drawing backwards. So it says the bearing of a lighthouse from a ship. So we're actually looking from a ship at the lighthouse, northwest. So when I draw this out, I'm going to be starting here at the lighthouse, or excuse me, at my ship, and I'm going to be looking northwest. And when I rotate that northwest, they said 52 degrees. So when I draw this, I'm now going to have this angle right here as 52 degrees from the north rotating west to this place right here, which we called the lighthouse. So again, be careful. Don't have your 52 degrees in the wrong direction or your lighthouse and ship flip-flopped. Okay. Then it said, second sentence, after the ship sailed 5.8 kilometers due south. Okay, so let me draw that in, and I'm going to use a different color to denote us moving. So now we just went 5.2 kilometers due straight south. Okay, and that was our ship. And the new bearing for that lighthouse again was north 23 degrees west. So when I go to draw this, now I'm going to be drawing from here, again, the north, and I'm going to rotate west again. And when I do that, and I draw this to there, that little angle inside of there is going to be that 23 degrees that we went. Okay, and hopefully you've noticed, as you could probably imagine, we were going to end up with a triangle. But notice it is not a right triangle. And so in this case, there's going to be a few things that we're going to have to find. Okay, and whether you want to label these as A, B, and C like you're accustomed to, that's totally up to you. I'm not going to. But in this case, they wanted us to find the distance to the nearest tenth between the ship and the lighthouse at each of its two locations. So what I'm going to do is I'm going to actually label these things as, I'll call this first one X, because that would be the first distance between the ship and the lighthouse, right? From here to here. And then I'm going to call the next one Y, because after it sailed 5.2 kilometers south, that would be the distance the ship is from the lighthouse the second time. So I'll call it ship number 2, its second position. So after doing all of the labeling, I noticed that I have a few things, and only one of them is really good right now and beneficial. And that is this 23 degrees in this angle right here. I also have this side length 5.2 kilometers, but those are the only angles inside of the triangle that I currently have. So can you guys see how I might be able to find another one? Because remember, we need 3 parts with one side. And you can see we definitely have that one side in order to solve. But right now I only have one angle and a side. And hopefully as you looked around, you're able to see that this angle right here is actually 180 degrees, a straight angle we called it. And we already know 52 of it right now. So if I take 180 degrees, that straight angle, and I subtract 50, which is 130, and then I subtract 2, which is 128 degrees, you can see that we actually just found this angle right here is 128 degrees, which is really nice because now we have two angles in one side. And if I know two angles of my triangle, I can actually find the third if I need it. And do I need it? Because I don't want to do extra work if I don't have to, right? Do I need that third angle up here in the upper left corner? And hopefully you noticed, unfortunately, yes, we do. Because if I know this angle here, then the side opposite it is the one side that we know. And we need that good ratio between the angle and the side. So I'm going to have to do a little bit more number crunching. And I'll go off to the side and I'll take my 128 that we just found and add the 23 that we had as my other angle inside. 8 and 3 is 11. 2 and 2 is 4, plus 1 is 5, and then one more. So we have 151 degrees inside of our triangle right now. We're going to take the whole triangle, which is 180 degrees, and subtract that 150, which is 30, minus one more to get 29 degrees. That would then be the other angle in that upper left-hand corner. So now that I'm given multiple parts of my triangle, we actually found 4 parts, right? All 3 angles. This one that we were given, this one that we knew was supplementary to that 152. And then since we knew these two, we found the third because we know their sum is 180 degrees. We also knew this side length here. So we are going to now be able to use the law of sines, and we'll first use it to find x. So I'm going to put x on top since that's what I want to find. And I'll put the sine of its angle that created it, which was the 23 degrees, set equal to the one side that I did know, which was 5.2 kilometers, over its angle that was formed by it, which is the sine of 29 degrees. And that's the hardest part, was first drawing it, and then secondly, figuring out all of those pieces that we needed in order to solve the 2 parts that we wanted. And that was the x and the y lengths. The other 2 sides. We're basically solving this triangle. So in this case, I'll take the sine of 23 and multiply it to both sides so that I get the x length by itself. Do a little bit of number crunching, and you will find that that length is 4.7 kilometers. Then we'll do a similar setup with the same triangle, but now to find our angle y. And so I'll put y over the sine of its angle that it formed, which would be the 128 degrees, that big obtuse angle. And then I'll set up my good ratio again, which is my side length over the sine of its angle that formed it. And then again, of course, we will take and we will multiply, which is why we put it on the bottom, and the thing that we want to find on top, by the sine of 128, so that that simply cancels out and we're left with what we wanted on the top, the numerator. A little bit more number crunching, and hopefully you'll get a length of 9.4 kilometers. Again, we would have used 2 sig figs just because of what they gave us originally, but they also said to the nearest 10th of a kilometer. So don't be afraid of the law of sines yet. I'll get to the special case in the next video, but this stuff isn't too bad. The hardest part is typically when you're having to draw things out like this, because if you don't set it up correctly, you got no chance of getting the correct answer. So be very careful with your drawing. Don't make it too small and cram things in where you can't even read your own handwriting. If you need to use arrows and point to it, that's fine. But just draw it and try to draw it as best as you can to scale. But most importantly, positioning the things in the correct places. And of course, to help you visualize this, what do we know always helps? Hopefully you said drawing. So I'm going to make sure that I draw this somewhat to scale. 127 degrees is the angle I have, and I have the two other letters. So in this case, I'm going to draw a 127-degree angle, which would be something like that. And one of these would be 12 feet long. The other would be 9 feet. And then this would be 127 degrees. And so hopefully you can already see that I'm going to have side, angle, side. So now I'm just going to draw my triangle so that you can see it a little bit better. And then I'm going to label my triangle DEF, putting all the places where they should go accordingly. So since they told me little d was 12 feet, I know that this is lowercase d, then this is going to have to be angle D. They told me angle E was 127, and then therefore this would mean angle F would go there, which lowercase f is opposite it for that 9 feet. And so hopefully you can see very easily that this is side, angle, side. And therefore to find the area, all I'm going to do is take 1/2 the two side lengths multiplied together times the sine of the included angle. And so I'll go over here and I will grab the 9 feet, the 12 feet, and the 127 degrees and multiply this all out. Now I can multiply in any order. So I already know what half of 12 is. That's 6. And then I have 6 times 9, which would be 54, times the sine of 127. That I would need a calculator for. So to find my final area, I'll go ahead and multiply that out. And remember, we only have 2 sig figs here and here. Even though this one has 3, we can't give more than the least number of sig figs. So my final answer would end up coming out to be 43. And remember, we're trying to find area. So my units would be, since it was in feet, square feet or feet squared. So that's it for this one. First little part of the law of sines, getting used to a couple different variations of it. Hopefully you felt okay and understood what's going on. If you need more practice, please do. Need any extra help, let me know. Hope you guys are hanging in there. So hopefully a good start to this new unit of study. Otherwise, keep working hard. I'll see you at the next video. Be well.